And we're live. Okay. Hello all, hello world. It is really, really cold outside. Yeah, it's not a great time to be, up relatively north above the equator. It's like -4 outside in Fahrenheit, so it's not ideal. This is day 145 of studying compilers every day until I land a compiler role. Last time we finished debugging our MR to LIR stuff. And that all kind of resolved itself. This time I'm not feeling like doing a whole lot of work. I'm kind of tired, so I'm gonna see if we can just like throw together some very basic sort of shaped regalloc thing. Just like putting together a liveness and interference thing, and then we will figure out how to assign registers from there. I guess we do need to like literally color the graph, I guess. Yeah, that's probably something I do need to do. Yeah, so we're gonna get that done at least and call that, I think, for the most part. I think there might have been pre-coloring things that I missed in interference that I probably want to get done, but for the most part it seems to have worked itself out pretty well. So yeah, I think all of this will kind of just focus on assigning registers, and we will see how that goes. So yeah, let's get straight into it, I guess. Yeah, so I guess we can start in the backend pile. Analysis, I guess we'll be using these, so we'll keep that to the side. Let's make like regalloc, and then make a header for it. Yeah, let's throw that together. Yeah, we could steal that real quick. We can. What's in max? How long did it take you to configure Neovim setup? Initially when I was like trying to set it up for the first time, it took like a day or two, I think. And then over time it's kind of evolved. I think it took about somewhere between 6 months to a year to get to a kind of stable point. I think like after 6 months I did one big rewrite. Kept some stuff that I really liked, got rid of some stuff that I didn't really like. Yeah, so I like messed around with that for a bit, and then from there it's been kind of stable, at least. You can like look at my commit history if you wanted like a more concrete example. I think it's in my old dot files, but you'd have to double check from there at least. Okay, so what else do I need to include? I don't need MIR, I think. Day 1 of trying config? Yeah, that is fun. Yeah, you will get there. I'm sure of it. Do we want to generate a new tree? I don't think. Actually, that might be easier now that I think about it. Because I feel like it's just kind of annoying to mutate the existing data structures. I guess we could look at our implementation and we can go off of that. It'll be a very fast peek. We have no setters. Do we need them? We'll probably need them anyway, or we could just replace the instructions. Yeah. Let's go, Scotch. Good to see you. How do we store these again? In a list? Yeah, it's in a list. So we could definitely just replace, I think. Let me look this up again. What am I looking for? It was C++ list. Let's go, Jenny. I'm also interested in compilers. What's your roadmap? What are you working on currently? Yeah, so I guess previously the stuff that I've come into this big project working on is, or like I have a lot of background knowledge from like, from just like a college course on like compiler front end and back end. I'm mostly going into this project just trying to learn about the middle end and more about like, more advanced, I guess, back end techniques. So yeah, that's kind of that's kind of what I'm focusing on here. I don't really have a good roadmap because like it's not really like studying by like reading. It's more studying by doing for the most part. Right now I'm working on a compiler from C to x86-64. Right now I'm working on register allocation because we have variables and we need to turn them into registers somehow. Is there like a swap or replace maybe? I guess we could just delete and then insert. Yeah, that would work actually. I guess erase and insert. That's good, Rami. Good to see you. What? Wait. So what does this return? Iterator following the last element. Okay. Or last removed element. So it's the next iter. And then inserts before? Or before. Okay. Yeah, so we can just erase and insert, I guess, and it'll be fine. Okay, so I don't think we really need a setter anymore then. Like, we will just regenerate these instructions. I think it'll be fine. Yeah, okay. So I guess that means we can make this void, I think. Or at least we can like do this in place in some way. So we want void regalloc, I guess. And then we can make this LAR program. This should be LAR. This feels like a strange interface. I feel like just using straight up regalloc feels strange. Maybe we could name it something better. But I mean, I'm not known for naming things very well. No, 2 Celsius to 0 Celsius. That is definitely that is comparatively nice. I would rather be there right now. It is like -4 Fahrenheit outside right now, which is definitely colder than -2 Celsius. Yeah, not a great time to be a resident of this current state. What do we want to do with this, actually? I guess we could do like allocate registers. We'll call it that, and it'll be well named. Yeah, okay. Let's make the body file, I guess. So we can include LR or regalloc like that. There we go. So that's a good start here. Good on hard. No, you probably won't understand a thing of that. I've already accepted that I will probably be not able to read the Scottish language. Okay, we'll move that over like that, like a lazy person. What else do we need to do here? I guess we could start by stealing the stuff from compiler real quick. So you can just like steal that there. So then we want like backend, we want backend allocate registers. Let's give it LAR. Yeah, that should be it, I think. For that at least. We also don't need this slush anymore. Much better. So let's steal that. Let's throw this there. Here we need... We can actually just steal that line. And paste that there. Yeah, okay. I guess maybe we could check for some other flags to like print stuff, but this is pretty reasonable, I think. Yeah, okay. We should probably add like ops levels to some of these, I think. Or at least like some of these functions that we're calling. Or at least like pass it around in some way. I'm not really sure what my plan for that is, but yeah, that could be something interesting. And I feel a headache. Okay. That's not ideal. I don't know. Maybe I should drink more water. I'm gonna get water real quick. I'll be right back. I promise this will be like half a minute. Okay. Got water. Music name, it's all a bunch of like Stream Beats stuff. It's like royalty free. I guess I should start adding it to the description, but copy link. There we go. Yeah, I got water. We're back in business. And also I turned on a light because it was quite dark in here. Yeah, average evening experience here. Okay. Let me click on some stuff real quick. Okay. So we have this pile. What do we do from here? We have an interference graph. I guess we could just step through the function, or we could do like a get registers visitor, I guess. I guess, I don't know. There's not a very fun way to do this. Yeah, that's kind of annoying, actually. How do we color the tree or color the graph? I guess let's pull out the big book. Full blind. Okay. regalloc. We're just gonna like skip the rest of the stuff in the middle of this for a little bit. Yeah, because right now my priority is just literally generating code, and then we can figure out better spill algorithms. Snowfall, yeah, I like that. I like that song. It's very nice when I'm not feeling the best and I just want to lay down and think for a bit. Okay, let's keep scrolling. This is not helpful yet. Over 300 different words for this word snow. That's pretty cool. Spill costs. Yeah, we are going to just be really lazy with spilling right now. If we can't spill, I guess I need just like a generic spill function probably. But something else I was thinking about is like, what we could do is we could also, yeah, like our current spill, our current like spill algorithm is just if if there is, or if there is any instance where we can't color, or if we can't, yeah, if we can't color the graph, we just spill everything and give up. That's like the most pessimistic graph coloring algorithm, I guess. We just give up on coloring, but we'll start with that. I think that's probably the least off, or like the least intensive algorithm, obviously. And then at some point we will have a proper like live range splitting slash just something to make things less awful here. Okay. This is kind of annoying actually, huh? I thought this stream would be like a little bit simpler. Which I guess makes sense because I have not been thinking very much about this. Okay. Interference, more interference. Huh. Okay, that's not really helpful. I guess we'll figure out what to do with it later. Maybe I should have just done linear scan. Why am I like trying to do graph coloring? This is like so much work. Yeah, linear scan would have been way easier actually, huh? Okay, well, future me problem. For now, let's figure out what to do with this. I don't know. What do we even want to do with this? I guess we could do like, we could just like loop through everything over here. Oh wait, there was pseudocode at the top of this, roughly. At least something like that. Oh, let's get Camacho. I'm like cleaning up my regalloc stuff right now. I'm trying to like put stuff together at least. Okay, so I guess we want coalesce. And then yeah, let's just we can do that. Yeah. Can we just like, can we just do that? Interference, and I guess we could do liveness, that, and then interference is interference. We can start with that, and then and here we want like, I guess change and that goes back to step 1, which is you make webs, adjacency matrix. Okay. So we do need to like rerun those over and over, I guess. We can do this, so while not changed, or false, I think, I guess. Wait. Wait, no. While. Wait. Yeah. Okay. We want change. So we want set this to true. Oh yeah. Do you think you'll create your own programming language? I think that'd be fun. I don't really know what I'd do with it yet, but yeah. There's a lot of interesting ideas that I'm kind of like thinking about at least. If I try to invite you to a Discord server for ambitious programmers, yeah. Yeah. I've not seen an invite yet, so I don't particularly know if that will ever show up, but you're free to do whatever. Yeah, let's do that. Yeah, so we can do. We could do like. What am I thinking about here? I guess we could have like the coalesce function like modified changed, I guess. Like changed equals I don't need the backend thing here anymore as well. We can do like try coalesce. We can implement that somewhere else as well. I'm starting to think that maybe we should just. I almost want to move liveness and interference just into here, because it's just like one giant file that would kind of be interesting. I don't know. There's a lot of like helper functions here that I think will just have to be here. Yeah, so we want to try coalesce. So we want to give it, what do we need to give that, I guess? I guess LIR and we'll do that. I guess we can just give it those, I guess. I think that would be good. I don't want to talk too much to the point others can't speak. I mean, like, it's an open chat. Anyone can talk. Like feel free to send messages. I'm like, I don't mind. Are you using Neovim? Yes, I'm very much using Neovim. Okay, so this is like kind of what we do for that sort of loop. So we're through here. Spill costs, I guess. Spill costs. I don't know. How would I go about spilling, actually? That seems, or at least spill cost wise, at least how would I do that? Prune graph. Wait, what? Oh, I see. Yes, we have that. Prune graph. And then I think I should probably do that, to be honest. That might be smart. Assign regs to the adjacency list to assign colors. Okay, so we definitely want that as well. So we want like assign. So we want to do that, I guess. Oh, that's really annoying. Okay. We might have to stick another while loop around this. Should always have a separate YouTube account for coding and programming videos. I guess that kind of makes sense. I could see that. I don't really understand why, but like the algorithm's always been kind of strange, so I guess that would make sense. Okay, so I guess we could do, I guess, yeah, this is fine, I think. Yeah, we can do that, and then we could do while true here. I guess we could do some like really screwy stuff. I don't know. We definitely need to throw this into a loop. I guess success, maybe. or we could do false, I guess. Or I guess we could do allocated, maybe. So we can do that. Yeah, so we could do like, I don't know. I guess we could do like, we could copy this thing. So yeah, I'll split it like this for now. Oh boy. Okay, let's nuke that. Okay, so we can build adjacency lists. That we don't care about, I think. So we compute spill costs. We can prune. We can do that. We can assign registers. Oh, I guess that makes sense actually. Okay, how do we do that? What do we even make this return be? Yeah, that's kind of awkward actually. Yeah, let's make a helper which is assign registers, I think. That's really awkward actually. If it succeeds, then we modify code. If it doesn't, then we do gen spill code. That is rough. That is very rough actually. I don't like if it's under 12 hours. I mean, I don't really think the length matters that much. It's up to you. Like, whatever you like. I think there's a lot of value being assigned to like how good a tutorial is just based on length, to be honest. Like, a lot of the work from tutorials just kind of comes from like doing the work yourself externally as well. And I don't think the length is particularly important there. Just as long as like it gives you like pointers on where to go. I think that is more than good enough for the average case tutorial, at least. Okay, so we want, oh boy. What do we need here? This is very annoying. I guess coalesce makes changes, right? Yeah, maybe it does. It definitely is in place, so we can do that. Okay, that will make that easier. Okay, and then so we just build the rest of the graph, and then we have assign regs here. Let's just split screen properly. I guess we could make this real quick. So we want, what do we do with this? What is this return type? This return type is actually very awkward, I think. Yeah, I don't really like this return type. We'll just do this for a second. Oh, yeah. We'll do that. Okay, so we want like, yeah, it's really annoying to figure out how to set up these functions. This is definitely not written in like a very useful way for me, at least. Hmm. Out array of, okay, I see. So that is, we just generate code, I guess. Huh. Oh, that's good, Niraj. Good to see you. I know you can't learn much from 10 minutes. I mean, like sure, as a full tutorial, but like, there's, like, I think like 12 hours as a floor is like a little bit too aggressive, at least. Regalloc is short for register allocation. Is how you map variables to registers as temporary. You're correct about it being short for register allocation. I'm glad that that has at least stuck across the past couple of weeks. Mapping variables to registers as temporary. I'm not sure what you mean by temporary there. Like, we are literally just replacing variables with registers is the goal. So, yeah, I don't really think that will. I don't really think there's like a notion of like temporary there, at least. I don't really know what temporary is referring to, at least. Okay, so we could do can assign, maybe? I don't really know what this looks like. It's 5 a.m? Well, yeah, get some rest. Yeah, you should definitely get some rest. Thanks for stopping by. Are you gonna put in memory but temporarily move into registers? No, we're gonna try to avoid memory as much as possible. But obviously there will be some times where not everything can fit in registers at once, in which case then we will spill to memory. Ideally we'd like to keep everything in registers as much as possible though. Yeah, that's kind of the whole point, at least. Okay, what do we do here? Where do we go? Assign stack locations and inserts or handles alternatively. Yeah, I guess that makes sense. Assign registers. Okay, so here's what we can do. So if assign registers, and this will, wait, that's really annoying though. Because we want to do it in 2 parts, at least, to like make a, yeah, that's not very fun. Because if it doesn't work, then we don't want it to commit the change. So what is this return type, at least? So we want assign registers. We want Lucky x8664 has lots of registers, yeah. I mean, a lot of them overlap, right? Or at least like the partial registers are no different than in x86. There are definitely like, obviously the new ones that it added, but I don't know. It doesn't change the algorithms at all. Like, all the algorithms are like register number agnostic, at least. So, yeah. What's the point of while changed? Because then we can do like a fixed point algorithm. So, yeah. So this line here, once that's done, we'll set change to true if something is changed, and then we just keep running it until it makes no changes. I've done this in a couple other points in my code. Yeah. If you want to just look up like while changed in my code, there will be a couple examples most likely. Maybe this could be like, how do we even represent that actually? What type is interference? We could just do an unordered map, to be honest, I think. instead of a map to set for that. At least we could make up a data structure for it. Yeah, that's really annoying. Yeah, that's super annoying actually. Okay. That's very, very annoying. What we could do is we could just do a size comparison against interference. No, we can't, because interference contains literally every register, so we can't do that. Okay, that's annoying. Project CMake and VC package. I guess that's fair enough. Yeah. Honestly, the average recruiter will not be building code, I fear. So, if you want to show it off, though, I imagine like there will be people that always will make an attempt to hack things together. Yeah, usually Windows is just hell, though, unfortunately. Yeah, so we can do that. We can do commit registers, and then we definitely want void spill, or we want something to do with spill eventually. I don't really know what to put in it yet, but we definitely need that. Maybe we put that at the top. Non-uni yet, sorry, do you have lots of time? Oh yeah, then you're in a very good spot then if that's the case. I don't know, just the other thing to think about is like how much effort do you want to like put into your project to like productionize it? Because like there's like a threshold where a project is like very clearly like a for fun project and you don't really like do a lot of like production stuff. So like use like a less insane like you don't necessarily need Postgres for like something where even just like SQLite would work, for instance, or like you don't need like the biggest example is like you don't need to set up Kubernetes for like your personal portfolio project, right? So like there are some things where it makes sense to like spend less effort, but just be intentional with it at least, because the instant that you get too far into, I guess, the realm where it's like fun, or like too into the realm where you're like doing production stuff, all of a sudden it's like it like kind of sucks a lot of the fun out of the project as well, because it's a lot of overhead to manage as one person, and there's like a reason that companies hire whole teams for it. Are you practicing leak code for interviews or same things? I've been kind of relaxing on leak code for a bit, to be honest. Like I have my internship for this upcoming summer, so for now it's just like literal knowledge for now. Maybe I'll relearn leak code properly from the ground up again at some point in the future. But for now, at least it's not that big of a priority in my head. Okay, so we want to spill code. Okay, so we want, I guess we could, that's annoying. That's very annoying. I guess we have spill already, so I think we could figure out what to do with that later. We can do this, I guess. I guess, do we want to just like do this as like a ternary? This is like really ugly. So if true, we commit, otherwise spill registers. Okay, we can do that, I guess. Let's just stick the to-dos in here. So that's where we actually color the graph, I think. Make changes to LAR. Here we make changes to LAR, I guess. Yeah, we can do that, I guess. This is very annoying. Okay, the other thing I need to think about is how I want to pre-color some registers, at least. Yeah. So we need to figure out what to do with that. Gen spill code. So that's spill. So we could do that. Or wait, no. We definitely want this to be. We definitely want if else actually. Yeah, because we want this to be like loop at least. So if we can't assign, then, or no, we could do this. So if assign, then we can commit and then break, I think is how we want to write this. Let's format, there we go. I messed that up very gloriously, I think. Right, there we go. Actually, we could just make this true. Okay, so then we can spill, and then I think we're good for that at least. And we can figure out what to do with those in the future. Where the hell is this extra? Okay, there we go. That's fine. Okay, and then we spill registers, and then I think, and then we like rerun everything again, and that's fine. This is very annoying. Yeah. Yeah, this is very difficult to at least think about, I feel like. Okay, and then we run this until we get here, and then we break. Okay, and then I think that's all we need for this. Yeah, we should be able to compile here at least, which is the really funny thing. We don't really do a lot with this, but we definitely can work. Are you reading the Mushnick book? Yes, that is my big reference. Yeah. we're having a good time. Okay. Spill cost, prune graph. Yeah, we'll do that. We'll do that eventually. Let's see if this builds, and let's see if this crashes things. This is fine for now. So let's run this on. Let's give it like, I don't know. Let's do square. Everyone loves this. Okay. So that works, I guess. How do you like it? Yeah, it's quite dense. I'm not really like following it as much as I'm just like using it as reference at least. Yeah, I've enjoyed working through it at least. So I would give it a solid recommend if its existence like matches your use case at least. Okay, what am I doing here? Okay, I guess we already do this, so this is fine. Or we attempt to do that, I guess. Oh boy. I guess also this also reminds me, we need like a separate like write to file thing instead of just like output. Yeah, what do we do with that? I guess we need like another, like, we need like an actual helper function, I think, somewhere here. Maybe I should just like make a macro file for all these like helpers, I think. I guess we're not really using output in like the way that we should, I feel like. Yeah, I need to like actually make that work is the other funny thing. I might spend some time doing that like somewhat soon. Yeah, I don't know. This is kind of fatiguing to just build all of this backend stuff at least. It feels like it's all just like very interconnected, and at least compared to like when I was doing middle and stuff or front end stuff, it's like a lot harder to like I feel like I'm doing a lot while spending a lot of time on one section. So this is unideal. Okay, what do I even want to do today with the rest of this though? I definitely want to do some more coding. I don't really know what to do though. Yeah, I guess we could do pool try coalesce. We can do something with that eventually. We'll just do that for now. We need to give it the proper parameters. Let's give it LAR, and we want to give it interference. So this is interference, like that. We can just do that. That's fine. Okay. So for now, we will just do nothing there, and that will be fine. Okay, so we want... Oh boy. What the hell do we do for spill costs, actually? This is like a whole nother analysis. We will deal with that eventually. I don't know if pruning the graph is like strictly necessary. I guess we could read about that real quick. Let's zoom out a little bit so I don't have eye issues. Interference graph. Coalescing. Okay, sure. Spill costs. Yeah, we can rematerialize some of these. That's fun. I just tried to use J to go down. Like, this is Neovim. God damn it. Maybe I should install Zathura. It's not on Windows, I forgot. That's really annoying. Okay, well that's fine. I will deal with it. I will cope. Okay, pruning. I see. May not result in art coloring, but very frequently makes more of the graph colorable. Okay, that makes sense. Have there been any math-heavy parts of compiler dev? Well, here is the math-heavy part. Like, this is an example of a very math-heavy part, actually. Just spot on right here. Aside from that, there are a couple of other... A lot of it's just, like, very graph-heavy. Like, when I was implementing, like, mem-to-reg, I was like low-key struggling, because I didn't really understand, or I guess like SSA construction slash to Reg. It's been there's a lot of graph stuff that I had to relearn. Abstract interpretation. What do you mean by that? Degree less than R rule. Okay, so a graph that contains no degree less than R. I see. Okay, I think I've like heard of this before. I've not like thought about it a lot, which is really interesting because I happen to have heard of it in class, I think. Okay, this makes sense. Too colorable, but not. So A is too colorable, but not by this rule. This one is 3 colorable, but not by the rule. Yeah. Abstract interpretation as in the branch of stack analysis that deals with approximated sets of it. I see. Yeah. That. I can't lie. My brain is like. I'm a little bit slow right now. Let me read that again. I see. Yeah, that is definitely another very math heavy part. Okay, so we have a heuristic. Okay, so sufficient. Okay. Optimistic heuristic generalizes degree less than R by removing nodes that have degree greater than R. I guess that makes enough sense at a glance. They need not all have different colors, and they may not use as many as R. That makes sense. So we use degree greater than R, or degree less than R initially. And then everything else we just give it a best shot. Okay. Cool. And then we color. Okay, I see. So this is... It's all in pruning, or is this separate from pruning? Or at least does Muchnick separate it? Okay, it is separated here, but like barely. Min color. Okay. That makes sense, I guess. Grr. Like value range analysis? Yeah, that makes sense. Modify code use yeah, we're literally speaking in functions here, which makes sense, but like damn. Okay, so we call modify code. So he's color to reg. Oh, I see. Okay, I see what's happening now. I see. That's probably where we could also pull in like the pre-coloring stuff. I guess, I don't know. There's not really a difference between these two, I feel like. I guess print. Global variable stack. God damn it. Ah, gar. Yuck. Okay. So look for, we have nodes. We look for nodes with less than our neighbors. R would be the number of registers we have. So that'd be like, what, 16? Each one we find, we remove and place on the stack. Wait. Is there like... Okay, this might be easier to read actually. I hope this is easier to read. If it's not, then like I'm gonna be in big trouble. Oh, these are comments. Okay, that makes sense. So then okay, so we go through webs. So I guess that would be, I guess that's our registers, sort of. Yeah, what are we doing here? Yeah. This is a good time. Okay. Success equals fall. Ugh. What? Oh, wait. I see. What the hell? What the hell? So we have success. I should probably read this more closely. Oh, what book is this? Advanced Compiler Design and Implementation. It's by Muchnick. What is happening here? What is real? Am I real? I hope I'm real. Okay, ion nodes are n-webs. Jesus Christ. Okay, this is rough. Let's go back to reading this. I do have resources for learning CMake. Low-key, I kind of just vibe coded it. Or I would, if I would go back, I would just vibe code it. It is not worth properly learning, in my opinion. If you want to like follow a specific resource, there was like a beginner CMake guide, I think. It was it this or was it that? Let's dark reader this. There we go. Was it this? Yeah, it was. I think it was this, right? Yeah, it is. It is like this whole cmake.org thing. This is like kind of what got me started, at least. And then from there, I kind of just looked at other people's cmake lists, and it got easier from there, at least. Yeah, it is unfortunate overall. You will just have to deal with, like, CMake is just a mess, and like it sucks to worry about, but like it is what it is. You will just kind of have to get used to it. Okay, let me figure out what is happening. So we repeatedly search the graph for nodes with less than our neighbors. Each one we find, we remove and place on the stack. Okay, so we know we have that stack. So we can retrieve them in backwards order. And remember the nodes that are adjacent, so they can be used during next section. Okay. If we exhaust the graph, then our coloring is possible. Yippee. Okay. Until success. Oh, I see. So that's like the while changed. Okay. Okay. Okay, that makes sense. Then we just color. Okay. Oh, next section is this. Okay, that makes sense. So if we exhaust the graph, then we're good. So I guess that's what's happening here. So otherwise, if it's not complete, we do the optimistic heuristic. So we choose the node, a remaining node, I guess, because that is exhaustive. And minimal spill cost divided by a current degree. So we do need spill cost. Okay, great. I guess we could simplify this as well. We could just like, what function is this? We could just do nothing there, I think. What is the point of this actually? Is this just like coloring? Because then why is it separated? Okay, not all the colors will be used for its neighbors. Postponing spelling decisions, okay. Before I move, okay. Pruning, oh, okay, that's the code. Difficulty of keeping the code and the interference graph synchronous. As pruning decisions are made. Avoid updating the code while pruning. I see. Okay, that makes sense, I guess. Jesus Christ. Okay, and then we do this until okay. So this is just coloring, I guess. Question mark. And then what do we do from there? What is adjust neighbors? Like, why? Okay. That's fun to read. Okay, great. Okay, so we're just adjusting the graph. I guess that makes sense. That's quite fair. So we have stack. I see. So that's what we get out of this. So I guess we could, this is like not really like pruning as much as it's just like tricolor, I guess? Or, yeah. Huh. Yeah. Yeah, I guess that is, I guess we have like overcomplicated a little bit. We'll throw a question mark there for a second. Yeah, what do we do from here, I guess? This is inconvenient. This is very inconvenient. We'll figure out what to do with this whole slush pile later. I think for now, we don't want to like have this explicit like prune graph thing, because I don't really think, I don't know, calling it like pruning doesn't really make sense to me. I don't really understand why that is. Like, is this not just coloring? I guess it is just coloring. Adjust neighbors. Yeah. We'll make it color, I guess. Alright, we'll just do that. We'll need to do something with that. I'm sure it'll make more sense if I think about it more, but it's not making sense yet, at least. Okay, so we want like color here, I guess. We'll do something with that eventually. We'll figure out the parameters to things eventually as well. We'll figure it out. we'll figure it out. Okay, so then after this point, so we have stack. Wait. Oh, so you just make the stack. I see. I guess that makes sense. That seems reasonable. Assign them colors. Okay, let's actually read the rest of this. I think that will help clarify a lot of things. Okay, so if we exhaust the graph, then our coloring is possible. I imagine we do the same thing after. Assign regs. Okay, so that is. Wait, what? Wait, so what is the difference? Yeah, so we do that routine. Just neighbors to effect. Effect, okay. Rule node. Okay, so we just make a stack. And then all of this stuff up here is... Or this thing is just assign regs, right? Or will that be explained here? The routine. Wait, oh, there it is. Let's see, pop. Okay. Yeah, I guess we'll just figure that out later. We just read the code, call it a day. It's min color, sure. Okay, we could do that, I guess. So then we can make like, we could just like give that a stack of register, or I guess list of register. But that's like kind of awkward. I don't know. We'll figure that out at some point. I think this is probably a good enough state to like leave the scaffolding up. The other thing I want to think about is how I want to scaffold, or how I want to break down future streams, just like off of the schedule. So obviously I was wrong here. So these are in fact necessary. We can skip coalescing copies for now though. Spill costs, I think we can skip somehow right now. I think next time we do like pruning and like start thinking about assigning, and then that will clean itself up. Spill we need to do something for, sort of interestingly. I guess we just need to like generate spill code. I guess we do need like a minus. We need a dash there. Okay, and then from there we can just do code run. Yeah, okay. This seems good. Let's commit some stuff. Let's make real quick. It compiles. It doesn't break tests. We infinite. Okay, that is not good. Where did I mess this up? Assign registers. Return true. We can commit and break. The hell? Color. Oh. So try coalesce. It does return true. That should be fine. Oh. False. That should be good then. Surely that should be good. Zoop. Okay, cool. Okay, let's add that. Oh, I should probably... I didn't push these yesterday? Push. Okay, let's merge this branch. Let's make a new branch. Okay, there we go. So then GitHub. Let's work off a new branch. This is kind of just the finishing stuff up thing. Ooh, Rust 1.93. Okay. Maybe I should like keep up to date with Rust and C++ updates. Now that I think about it, that might be smart. Okay, so what do we change here? So we have yeah, we can do that. Yeah, okay, that seems sane. Let's do markdown. Pull request. While we're at it, while we wait, git switch main. Give it a second. This will take a second. Yep, still running. Yeah, while we wait for this, how's everyone's day been? I know at least over here where I am, it is incredibly cold. Hopefully y'all have it a little bit better where you are. The Midwest is not doing so hot right now. We're just staring at this. Yeah, by God, GitHub is slow. Very cool, yeah, man. Yeah, it's rough out there. Do you have any tips for taking what you read in books like Muchnix and actually translating that idea or thought to code? Not really, to be honest. That's something I'm still trying to learn. Yeah, I do not have enough practice with it. I would like more practice with it. I guess that is part of what I'm doing here. Okay, that works. Let's rebase. Let's delete branch. Okay, we pulled. Regalloc. Let's pop stash. Okay, initial regalloc build out. Yeah, you bet, not build out. Scaffolding, because we didn't really build anything. Okay, cool. Should be pushed. Let's see. Is main running a check? Yeah, it is. Okay. Let's make the draft PR. Regalloc. Okay. Let's just. Oh God. Yeah. No. Da. Soup. Right? Okay. No. Okay. How did this work in space? Space and space. There we go. Okay. Okay. I think that is a sensible spot to leave off, though. Yeah. It's low-key like very taxing to go through all of this. Not in like a not in like a life sucks way, but in like taxing as in like I have to think about things a lot, and it's like, it's hard to really like do a lot of thinking in one sitting while doing all of the like data structure design and just like dealing with everything. So I think like I will have to like shorten streams a little, just inevitably due to that. But hopefully it's not too bad. I have some compiler books which don't hand feed code, and I often have trouble reading books and thinking how I take this and transfer it into code. Yeah, I definitely feel that. Like I guess that's part of the learning as well, though. So I think that's like kind of an interesting exercise in and of itself. It's difficult, but like eventually it gets done, and it's probably a learnable skill. I have yet to learn it properly, or I have yet to get a lot of practice with that skill, but I imagine it's something that could be done with a lot of time. But yeah, thank you all so much for showing up today. If you haven't already, make sure you like the stream and sub to the channel. It helps out a lot with the algorithm and gets my content out to more of you. While you're down there, make sure you check out the description. Join the Discord if you haven't. It's the best place to get pinged when I go live. Also down there is my GitHub and my LinkedIn. I haven't really checked them, but feel free to add me on those. And also my GitHub sponsors is there as well. Yeah. Take care, y'all. Take it easy. I'm going to eat dinner because I'm really freaking hungry. Yeah. Have a wonderful rest of your day wherever you are. Also, if it's cold, stay cozy. Yeah. Also do that.